This is the demo for lesson 20 for college algebra. The standard form of a quadratic function. So in the preview, we talked about the general form, which was ax squared plus bx plus c. This is called the standard form, also sometimes called the vertex form. And it's a times x minus h squared plus k. You can find many key features of a parabola by looking at the standard form and identifying the transformations from the graph of the parent y equals x squared. So does changing the values of a, h, and k affect transformations of the parent function y equals x squared? All right, so which constant affects the shape? That would be a, the one that you're multiplying by. Which constants affect shifts? That would be h and k. The leading coefficient a for a parabola written in standard form tells us whether the parabola opens up or down. If a is positive, the parabola opens up, and if a is negative, the parabola opens down. Right, up like that, or down like that. And when the absolute value of a is bigger than 1, so if a is a big number, then we are getting the parabola is a vertically stretched. Where we do our y values times a. And if a is a small value, like a fraction, the parabola is vertically shrunk. Again, by a factor of a, we're doing y times the a values, and that will give smaller y values because a is a fraction. Okay, what does the graph of a quadratic function look like as the leading coefficient gets closer to 0? That is what happens when a gets closer to 0, or what happens when it is 0. So when a gets closer to 0, picture this graph. We know that when a is a fraction, we're going to have a vertical shrink, so it's going to get like wider and wider and wider. And then when a is 0, it's going to be sort of as wide as possible, and it will be a flat horizontal line. Okay. So it approaches the horizontal line y equals k. And then let's examine what the constants h and k do to the transformation. So h is inside the parentheses, so this is going to be horizontal, and it's a shift, the opposite of what we think. So if h is a positive number, like 5, this would say like x minus 5, that would mean we're going to go right 5 units. And when h is negative, if this said x minus negative 5, that would really be x plus 5, and that would mean we go left 5 units. Oh, not 5. 5 is just a stand-in h. In general, it's h units. Go right h units and go left h units. And then the constant k is our vertical shift, and when k is positive, we go up k units. And when it's negative, we go down k units. The standard form is convenient. That's this one up here, a times x minus h squared plus k, because it helps us identify the vertex of the parabola at h comma k. So you can just quickly glance at this and know where its vertex is. In this form, h has the opposing sign and k has the same sign. And so sometimes it's convenient to change from this general form, ax squared plus bx plus c, to the standard form that we like because you can identify the vertex easily. So we just need to calculate somehow a, h, and k based on a, b, and c. So finding the value of the leading coefficient a is relatively easy since it's the same in both the standard and the general form. So there's an a in this one, there's an a in this one, they're the same. They're the same a. So if you know this a, you can put it here and you've got it. And then the x-coordinate of the vertex of the parabola, ax squared plus bx plus c, we calculate by doing h equals negative b over 2a. The y-coordinate, you just take whatever you got for h, plug it into f, and you'll get k. And then once you know A, H, and K, you have everything you need to write the standard form. You can also find x and y intercepts if you want to make an accurate sketch of a parabola. So let's do an example. We're going to use the following steps to change the quadratic function f of x equals negative x squared plus 4x plus 1 from general form to standard form. So it's going to look like f of x equals x minus h squared plus k, and we just have to plop in an a, an h, and a k. So it'll look like this. We're going to put a number there, a number there, and a number there. So which of these values can we find immediately? It's the a, right? So the coefficient on x squared is what goes in that first box there. So we would say a we can find easily, and it is -1. The coefficient on that x squared is a -1. So does the parabola open up or down? Down. Okay, when a is negative, the parabola opens down. Next, we need to find the vertex. So we can find h using -b over 2a, and we plug it into the function to get k. So h is -b over 2a, and -b, that would be -4 over 2 times a, which is -1. -4 over -2 is 2. So I know the h, and then I just need to know the k, and that's just f of 2. Once you have h, plug it into f, and that'll give you k. So I have -2 squared plus 4 times 2 plus 1. So it's going to be -4 plus 8, which is 4, plus 1 is 5. Okay, so I know the vertex, h and k, 2, 5. So now we can graph it, because we can first write it in this vertex form or standard form. So I'm going to put my a there, my h there, and my k there. It's going to be -1 times x minus h squared plus k. And then we're going to find a few other key points, an equation for the line of symmetry, and we'll find the y-intercept and the x-intercept, if there are any. And another point is the point that's symmetric to the y-intercept on the graph. Okay, so before I start, I like to put the vertex down first. So I have 2, 5. There's my vertex. I know it opens down. It would be very convenient if I knew the x-intercepts. Where does it cross the x-axis? Where does it cross the y-axis? That will help me draw this graph. And then the equation of the line of symmetry, that's this vertical line that goes through the vertex. So that vertical line, every point on this line has an x-coordinate of 2, which means that's its equation, x equals 2. And sometimes it's helpful to draw in a little dashed line. It's just a guideline. It's not part of the graph. It's the axis of symmetry. Okay, so the y-intercept would be f of 0, which would be -0 squared plus 4 times 0 plus 1, which is 1. So my y-intercept is 1. Now, because this line is an axis of symmetry, this y-intercept has a symmetric point on the other side of the line. So if I just go to the line, then go the same distance over, it looks like it's at 4, 1. So that point is symmetric to the y-intercept, and it's also on the graph, 4, 1. And then, oops, sorry, I'll put that in the spot for the y-intercept, which is 0, 1. And then this one is at 4, 1. And then find the x-intercepts. We take the function, set it equal to 0, and solve for x. I think it will be easiest to use the general form, -x squared plus 4x plus 1. We'll set that equal to 0. I don't think it's going to factor, so we'll have to use the quadratic formula. X is -b plus or minus the square root of b squared minus 4 times a times c all over 2a. And that comes out to negative 4 plus or minus root 20. 16 plus 4, yeah, root 20. Over negative 2. And let's just get an approximate value for that because we're trying to put it on the graph and I need an approximate value to be able to do that. Okay, so I just used a calculator to get approximate values of negative 0.23 and 4.23. So negative 0.23, that's about right here. And 4.23, that's about right there. And then I have enough points that I could confidently connect them, and then continue the graph in the same direction to create my parabola. Okay. Finally, how would I change the function back into polynomial or general form? So from this form, how would I change it back to this form? We just multiply it out. So I would say f of x equals negative x minus 2 squared plus 5. Just follow the order of operations and multiply it out. So I have negative x minus 2 squared is x squared minus 4x plus 4. Okay, distribute the negative sign, and I'm going to have negative x squared plus 4x. And then I'm going to have minus 4 plus 5, which is plus 1.